Hello and welcome to Algebra 2 with Mr. Clausen. Today I'm going to talk about graphing parabolas using quadratics in Vertex form. And specifically what I want to talk about today is how to analyze quadratics in Vertex form. And then we'll look at how to create Vertex form equations from a graph, and then also how to determine the y-intercept of a Vertex form equation. And so with that said, I'm going to get started here because I got quite a bit to talk about in this given video. Now, what I want to show you here is what the typical Vertex format is for a given quadratic equation. So this is different from the standard form equation, and with that, some of the variables are a little bit different. The a term here is shared between the Vertex form and the standard function notation. And so that's useful to know in that, if you have an a term that's positive or negative, you still understand that the slope is opening upward or downward. But now you have this h term and this k term. And just like we've talked about with other types of functions, when we've looked at h and k of absolute value equations, for example, they mean the same type of thing that's occurred previously, where the h term is the horizontal shift, and the k is the vertical shift. And with that information, we can combine those things just like we've done with absolute value equations and understand that the vertex is going to be represented by h comma k for any of these given situations. And so what I can do with this information and understanding that vertex form is very similar to absolute value equation format, is I can look at an equation like this and understand that my a term is equal to 1, which tells me it's an upward opening parabola. I understand that this is x plus 3, so if I'm looking at this as an x minus h circumstance, then h would have to equal negative 3, and so we have a leftward shift of negative 3. And then we have a k value of negative 4. So there's a downward shift of negative 4 for our k term. And so with this, again, we can combine these two pieces of information, and we can find that the vertex of this given quadratic equation, or the parabola for this quadratic equation, is equal to negative 3 comma negative 4. And it probably goes without saying, but the reason that we refer to this format as the vertex form equation is simply because they literally give you what the vertex of the equation is, which can be really useful. So if I know that my vertex is at negative 3, negative 4, I can just plop that point right there, and I know that this is my vertex. And if I want to go find some other points, let's say, hey, I understand that that there's a bit of a shift here. So if I go and I say like x is equal to 0, all right, that'll give me 3 squared, which would be 9 minus 4. That's going to be equal to positive 5. That would represent our y-intercept there. That would represent our y-intercept there, or be the c term if you're going to rewrite this in standard equation. And I can very quickly plot this out and try to draw it. Let's say if x is equal to negative 2, maybe I should make a t-table here, all right? So I understand that with x and y, if x is equal to negative 3, that cancels this out. That either minimizes or maximizes this point, just like we talked about with absolute value equations. And then y is equal to negative 4. If I plug 0 in for x, you get 9 minus 4, which is 5. And let's say I plug negative 2 in for x. That'll be negative 2 plus 3, which is 1. 1 squared is 1. 1 minus 4 is negative 3. And again, I'm going to do the same thing I've done with some of these other videos, is just pick 3 points, then find the corresponding points, and then I can very quickly graph this parabola representing this quadratic equation. And it can be a really quick way to find this information because, again, just as the vertex form states, it just gives you the vertex in the equation. And so with that, let's look at a second example. All right, now I have an a term that is equal to negative 1/2. I understand based on this that this is going to be a downward sloping parabola. H is equal to 2 because the h equals 2 in order to fit that given context. K is equal to 1. So the vertex for this given situation is equal to 2, 1. And so I can just go find 2, 1. I can plug that in. It's a downward shaped parabola. Just going to pick out that point there. My axis of symmetry has to go through that vertex. That's just an assumption that I'm making, but since I know the vertex, I also know where the axis of symmetry is. And if I just go start plugging in some values, let's plug 0 in for x. Let's make a t-table again. X and y. When x is equal to 2, y is equal to 1. We already have that point. If I plug 0 in for x, 2 squared is 4. 4 times negative 1/2 is negative 2. Negative 2 plus 1 is negative 1. And so let's also plug in 1. 1 minus 2 is negative 1. 1 squared is 1. 1 times negative 1/2 is negative 1/2. Negative 1/2 plus 1 is just 1/2. Alright, so at 1 we have 1/2. At 0 we have negative 1. And again, we can very quickly graph these points. And you can pick any points that you want when you're doing this. But again, like I said, I generally like to find 2 points, then dot out their corresponding points. And generally with that, I can very quickly draw out this parabola and get a very clear idea of what it looks like. I don't need to trace out infinite points. What I'm just trying to do is get you acclimated to the basic mechanics of these quadratic equations so that you can graph out a rough parabola to represent it. Let's look at another example here. So now I want to take a parabola with a couple of given points, and now I want to take that and form an equation from it. Now, because I'm looking at this and I see 1, 2, and 3 variables, there are technically 3 unknowns that I need to figure out. So with that said, I either have to have 3 ordered pairs in order to do this, or I need the vertex and one other ordered pair. And the reason for this is because the vertex actually gives you 2 unknowns in one fell swoop. So if I look at this, I can already tell you based on this that this is the h value and this is the k value. And so if that's h and k, we can just simply plug those in and say y is equal to a times x minus 0 squared plus 4. And now all I have to do is I have to take the other ordered pair here and just simply plug it into the equation I have here. And so I'll plug 3 in for y is equal to a times 1 minus 0 squared plus 4. And I can find pretty quickly, with a little bit of math and rearrangement, that negative 1 is equal to 1 squared a is equal to negative 1. And just from a couple very brief pieces of information and the vertex, I can find that the vertex form of this equation is simply y is equal to negative 1 times x minus 0 squared plus 4. And because I'm asking specifically for this equation to be in vertex form, I'm going to leave it as x minus 0 since it clearly lays out the points of the vertex. Alright, so that's the only reason I'm going to do that. Otherwise, it looks more like it's in standard form than in vertex form, but that's a very minor thing that I'm just going to point out right there. So another example that I want to look at here is creating a vertex from equations from a graph where we have 2 points and an axis of symmetry. And I'm going to consider this axis of symmetry sort of as a third ordered pair, even though it's not. I can't really go say that this is 1, 2. It doesn't tell me specifically that, but even with this information, I understand that the x value of my vertex is represented here. So if we're looking at the h and k, I don't know exactly what the k is, so I can't go out and expect that, but I understand that my axis of symmetry is the same thing as the h value here. So I can go and clearly see that h is equal to 1. I can also tell you that a is a negative term here, and so that might be helpful to keep in mind, but it doesn't narrow anything down. So how we do this next step is we're just going to plug in these coordinates into the given format here, assuming that h is equal to 1, and see if we can whittle something down. And so, for example, I'll just take 2 and 1 and plug it into this coordinate and say 1 is equal to a times 2 minus 1, okay, the ones from the h here, the ones from the ordered pair here, plus k. I have 2 variables. There's nothing I can do about that right now, but I can say 1 is equal to a 2 squared, or 2 minus 1 squared is just 1 plus k. And what I'm going to do is I'm going to go and I'm going to subtract a from both sides and get a 1 minus a equals k type circumstance here. Now I'm going to do the same thing with 3, 2. Right, but I'm going to take 3, 2 and kind of loop it around here and combine it with this. And what I'm going to get here is I'm going to get negative 2 is equal to a times 3 minus 1 squared plus k. Now, you might be thinking, why am I doing this? What's the idea here? And really what we're doing is we're applying some of the same knowledge that we've used from like 3 variable systems to go. Just plug each piece of information into the equation individually, and as a result, what you hope to get is a situation where you can say negative 2 is equal to 3 minus 1 is 2, 2 squared is 4, plus k. Let's go and subtract 4a from both sides, and we'll get negative 4a, let's just go negative 2 minus 4a is equal to k. And the idea here is that we have these 2 equations that we can now bring together using the transitive property and say that 1 minus a is equal to k and negative 2 minus 4a is equal to k. So we can say negative 1 minus a is equal to negative 2 minus 4a. I can add a to both sides. I can add 2 to both sides. I can find that 3 is equal to negative 3a, so a must be equal to negative 1, which fits our original observation here. If a is equal to negative 1, 1 minus negative 1 is equal to 2, which is what our k represents, and therefore the equation for this specific parabola must equal y is equal to negative x minus 1 plus 2. And we can find that very quickly for this given circumstance. So the last skill that I want to talk to you about is how to determine the y-intercept of a vertex form equation. And there's really one of 2 ways that you could go about this. One is that you could go and figure out what the equation equals if we just plug x equal to 0. This might be the easiest way to go about this, because if you plug x equals 0 into the equation, well, you understand that the y-intercept should occur when x is equal to 0. And so we can just say y is equal to 0.1, and we plug 0 minus 3.2, and we square that. If we square 3.2 and multiply it by 3.2, we should get 10.24. And if we get 10.24 and we multiply that by 0.1, we would find that the y-intercept for this given point would be 1.024. And it can be as simple as that to find the y-intercept for this given situation, because you understand that the y-intercept is always where x is equal to 0. The other method that you could use is either graphing to see where it physically crosses the y-intercept, or you could actually solve the equation in standard form. And so this is just done by saying x minus 3.2 times x minus 3.2. And what you'll find is that if you go and FOIL out these two halves of the equation, do firsts, outsides, insides, and lasts, what you'll find is that you'll get x squared minus 6.4x, and when you multiply the 3,2 and the 3,2 just like you did down here, the positive 10.24, all multiplied by the 0.1, and the standard form equation for this would be 0.1x squared minus 0.64x plus 1.024. In there, you would have your c term, which is also your y-intercept. So with that said, I'm going to leave you to it, and let's do some math.